Welcome back to the deep dive. We got this great question from a listener basically asking, what if you just jumped into Saturn?
Right, which sounds maybe not advisable, but it got us looking into this really cool YouTube exploration.
Yeah, it's called What If You Jumped into Saturn? It takes this hypothetical leap, but uses real science to imagine the journey.
Exactly. So we've kind of gone through that, pulled out the bits that really made us go, whoa.
Definitely. So the mission for you today, listening in, is to get past Saturn just being the planet with the pretty rings. We want to dig into what makes it truly, well, weird.
And maybe a bit terrifying. Okay, so visually, Saturn's the star, right?
Right.
The it girl, as the video called it. Those rings are just stunning.
Absolutely. But straight away, there's this fundamental puzzle even before we think about jumping in.
Yeah, the energy thing. Saturn actually pumps out roughly twice as much energy as it gets from the sun.
Which is wild. It's like it has this internal furnace going, and scientists are still, figuring out exactly why.
It really makes you rethink how these giant planets work, how they hold on to heat or generate it over billions of years.
Okay, so that's one mystery. What about that hexagon? That thing is just bizarre.
Oh, yeah, at the North Pole. And it's not just some weird cloud shape. It's huge. We're talking, 14,500 kilometers long?
And nearly 29,000 wide. That's more than 6 times across the mainland U.S. It's hard to even picture that scale.
And it's stable. It just sits there. How does that even happen? Plus, remember the color change?
Oh, yeah. The winds inside it went from blue to a golden color a while back. Nobody's quite sure why.
It just shows Saturn isn't this static, perfect ball. It's dynamic. Things are happening.
Like the Great White Spot, too. That massive storm that pops up every 30 years or so.
Last seen in 2010, yeah. So our hypothetical jumper might miss that particular spectacle, maybe luckily.
Oh, maybe. Okay, let's talk rings. They look so solid, but the video really emphasized how incredibly thin they are.
Totally. They stretch out 280,000 kilometers across. Massive. But they're only about a kilometer thick.
Practically two-dimensional, like a giant cosmic vinyl record or something.
Kinda, yeah. And what are they made of? Millions of bits of mostly water ice, some rock, some dust.
And maybe, just maybe, the pulverized remains of old planets. That's a pretty cool, if slightly morbid thought.
It is. Adds a bit of history to them. And the naming, oh boy, it's not exactly logical, is it?
No, E, G, F, A, B, C, D. It's just the order they found them in, right?
Yeah.
Not distance or anything sensible.
Exactly. So the E-ring is furthest out. And what's cool is that it's constantly being fed by Enceladus.
That little moon,
Yeah.
tiny thing, 7 times smaller than our moon, but it's shooting out these huge geysers of ice and water.
Yeah, and that spray basically becomes the E-ring. Shows how even small moons can have a huge impact.
Really drives home that interconnectedness. Okay, then the F ring. The video described it as thin, narrow, kind of messy.
Yeah, dynamic is the word. It's kept in line, sort of, by 2 little shepherd moons, Prometheus and Pandora.
Their gravity pulls and pushes on the ring particles.
Pretty much. Stops it spreading out, but also creates twists, clumps, even braids in the ring structure. It's like gravity is weaving.
Cosmic weaving. Love it. Then you get the big bright ones, A and B.
Right, the most obvious rings. And they're separated by that big gap, the Cassini division.
Which is, over 4,800 kilometers wide? That's a serious gap.
And it's likely carved out by another moon, Mimas. It's not huge, maybe 200-kilometer radius, kind of lumpy looking.
But its gravity is enough to clear out that whole zone.
Wow, yeah, through orbital resonance, like it's pushing particles away. But there's a sad part.
Oh.
Well, Mimas is slowly drifting away from Saturn. So in maybe 40 million years, the Cassini division might actually close up again.
Huh. So even these huge structures aren't forever.
Yeah.
Okay, what about the C ring?
Closer in, that one gets affected by Titan, Saturn's biggest moon. It causes these gravitational tsunamis.
Tsunamis in the rings.
Yeah, like these ripples, walls of ice particles, maybe 2 kilometers high, moving through the ring. Sounds dramatic, but apparently they move pretty slowly.
Still, wouldn't want to run into one. It sounds like just getting through the rings would be a challenge.
Definitely hazardous. And speaking of things ending up in Saturn, Cassini.
Right, the spacecraft.
Yeah.
They crashed it into Saturn deliberately in 2017.
Yeah, it was such an amazing mission, gave us so much data, but they crashed it to make sure it wouldn't accidentally contaminate moons like Enceladus or Titan, which might, just might, have conditions for life.
A responsible end, then. The video even suggested its bits might now be part of the rings.
A poetic final chapter. Okay, rings navigated. Now for the plunge itself. First weird fact. Saturn would float.
Get out. Really?
This-
A whole planet.
Yep, it's the only planet in our solar system less dense than water. Find a big enough bathtub and it floats. It's just counterintuitive for something that massive.
Mind
If we-
blown. Okay, so as we fall in, what's the air like?
Well, air isn't quite right. It's mostly gas. About 75% hydrogen, 25% helium,
Yeah.
with traces of other stuff like methane, water, ice, deeper down.
And the structure inside is like layers, right? Gas, then liquid hydrogen.
Then metallic hydrogen, and finally a rocky core, probably. That's the model.
So you hit the top layers, the troposphere near the equator. It's cold.
Yeah, really cold. Minus 75 Celsius, roughly. And this is where the winds are just insane.
Because Saturn spins so fast.
Exactly. A day is only like 10.5 hours. That whips up the atmosphere, especially at the equator. Jet streams up to 1,800 kilometers per hour.
It's 4 times faster than Earth's strongest hurricanes. You'd be torn apart instantly.
Pretty much. Okay, descend about 100 kilometers further. First, main cloud deck.
And this one smells bad, right? Ammonia.
Ammonia and ammonia ice, yeah. Pungent, apparently, and really cold, like negative 250 C. This layer is what gives Saturn its yellowish color. Pressure still lowish, maybe 40% of Earth's.
Okay, keep going down. Next layer.
About 170 kilometers below the top, ammonium hydrosulfide clouds, and the smell, according to the source, gets worse.
Oh, great. Like what?
The video mentioned urine and farts, so not pleasant. Temperature warms up a bit to negative 70 C, pressure's about 1.7 times Earth's.
Lovely. Deeper still.
Yep, down to about 220 kilometers below the top. This is the deepest cloud layer we can sort of see into. Water ice, ammonium droplets, it's thicker, maybe 10 kilometers thick.
And the temperature. Pressure.
Temperature gets up to around 0 Celsius, freezing point of water, but the pressure is now serious, about 10 times Earth's surface pressure.
Okay, so below the clouds, things get really weird.
That's where the hydrogen starts to change. Go down maybe 500 kilometers from the top, and the pressure hits 1,000 times Earth's pressure.
Wow. And that does what?
It crushes the hydrogen gas so much it becomes a liquid. You're basically falling into an ocean of liquid hydrogen.
An ocean, but hot.
Oh yeah, not refreshing. Around 730 degrees Celsius down there. And this liquid hydrogen layer is deep, like 60,000 kilometers deep.
60,000 kilometers. That's almost the diameter of Earth. Just liquid hydrogen.
Insane, isn't it? And the pressure just keeps building as you go deeper into this ocean.
How high does it get?
Eventually, it reaches something like 2 million times Earth's atmospheric pressure. 2 megabars.
I can't even comprehend that kind of pressure. What happens then?
The hydrogen atoms themselves are crushed so intensely that their electrons get squeezed off, basically. They become free to move around.
Just the hydrogen starts acting like a metal.
Exactly. It becomes electrically conductive. This is metallic hydrogen, a whole layer of it, maybe 30,000 kilometers thick, surrounding the core.
Metallic hydrogen. That's just, wow. And the core itself.
If you could somehow get there, the temperature is estimated to be around 5,700 degrees Celsius.
Yeah.
Hotter than the surface of the sun in places.
Unbelievable. Just an environment of absolute extremes.
Totally. So yeah, let's quickly recap those shockers. Saturn radiates more energy than it gets. It's got that giant, weird hexagon storm. The rings are huge, but paper-thin, made of ice and debris.
And beneath the clouds, it's not just gas, but this vast, incredibly deep ocean of liquid hydrogen, then metallic hydrogen, all under unimaginable pressure and heat, wrapping around a rocky core.
The big aha for me, is just how different the reality is from the beautiful, serene image we see through a telescope. It's dynamic, violent, extreme.
Absolutely. It's a world shaped by immense forces, bizarre weather, states of matter we barely understand.
And it really makes you think about scale, doesn't it? How tiny moons can sculpt features across hundreds of thousands of kilometers just through gravity's persistent pull.
It does. And it leads to that final thought, right? If Saturn, a planet in our own backyard, relatively speaking, holds these kinds of surprises, these kinds of extreme conditions.
And what else is out there?
On all those exoplanets we're finding, what kind of bizarre physics and environments are waiting beyond our solar system?
Makes you wonder, doesn't it? What hypothetical journey would you, listening now, want to take next? Something to ponder. Thanks for diving deep with us today.